Alright, we need to set up page 9 for Cornell Notes. You need to write the date, the topic, the objective, and the essential question. That's something new that we added this time. We have actually 3 essential questions. What is matter? What is an atom? And what are the subatomic particles of an atom? And that's what we'll be covering. Don't forget you need to draw a line about 1/4 to 1/3 in from the left side of the paper, and that the notes are going to go on the right side. And I think most people are needing 2 pages for notes, so just wait to draw your summary line until you have finished taking the notes. And if you need, you can continue your notes on the next page. Don't write on the back of the one that you're writing on, just go on to the next page. That way we don't have to do any more gluing to the bottom of your page, and make it a little bit easier. We've already talked a little bit about matter, but let's go ahead and review. Matter is anything that has mass and takes up space. It includes everything that can be seen, tasted, smelled, or touched, but it does not include heat, sound, or light. Matter is made up of elements or combinations of elements. An element is a pure substance that cannot be broken down to simpler substances by physical or chemical means. An atom is the smallest particle into which an element can be divided and still be the same substance. For this part you do not need to take notes. I just want to give you a little bit of the background of how the atomic theory came about. Way back in 440 BC, a Greek philosopher named Democritus said that if you cut a substance in half again, and again, and again, eventually you'd have an uncuttable piece. He gave that uncuttable piece the word atomos, which means indivisible. Since Democritus, there were lots of scientists who contributed to the development of the atomic theory. But let's fast forward to 1913, to when Niels Bohr decided that electrons travel around the nucleus in definite paths. The reason why we're talking about Niels Bohr is because later we're going to use his model when we start to diagram different atomic structures. And let's fast forward again to 1926, where Erwin Schrödinger and Werner Heisenberg decided that electrons travel in clouds, but not definite paths, so they kind of contradicted what Niels Bohr had said. We still use the Bohr model, though, to represent atoms today.
Oh, babe, check this out. Hey, come on. You want to look to me? You want a Dorito? Are you hungry? Come on and get a Dorito.
Babe, don't hurt my dog.
Come on, get a tip. Come on, get a tip. Get a tip. Come on. Hurry, go. That's what it is.
Alright, we need to start taking notes again. In your notes, you need to create this diagram. Make sure that you label the nucleus, the neutrons, the protons, and the electrons. Also, pay attention to the protons and the electrons. They have a sign that indicates their charge. The protons are positive and the electrons are negative. Let's look at protons. They determine the identity of the atom. They're positively charged particles, and they're found in the nucleus. Their mass is really small. And each proton is 1 AMU. AMU stands for atomic mass unit. That is much easier than trying to write out what you see above. In your notes, please don't write what's in white. Alright, now neutrons. Those are kind of like the glue that holds the protons together in the nucleus. They don't have a charge, and their mass is also 1 AMU. And electrons, they determine the reactivity. What that means is the number of electrons has an influence on how atoms combine together. They're negatively charged, and they're found around the nucleus within electron clouds. Their mass is very, very small. It's almost zero. Atoms are neutral because the number of protons equals the number of electrons. In your Cornell notes, you need to draw this square. This is a square that you would normally see on the periodic table, and it has information about each element. They're identified by their atomic number, and that's that top number, 8. It's also the number of protons, so it's important to remember that the number of protons identifies that particular element. It also equals the number of electrons, so if there are 8 protons, then there are also 8 electrons. You also have the chemical symbol, O, which is for oxygen. Sometimes you'll find the element name on the square, but not always. And then you'll also have the atomic mass. One thing the square does not tell you is the number of neutrons. In order to find the number of neutrons, you have to round the atomic mass and subtract out the atomic number. So in our case, the number of protons is 8, which is the atomic number. It's also the number of electrons. To find the number of neutrons, we're going to take 15.9994, we'll round it to 16, subtract the atomic number, which is 8, and that gives us 8 neutrons. Although in this example all of the numbers are the same, it will not always be the case for every element. This concludes our notes. Make sure that you go back and you write the questions on the left-hand side that correspond with the information that's on the right, and you complete a summary that's about 4 to 5 sentences long that answers the questions that you wrote and also the essential questions at the top of the page.